Welcome back. In this video, we're going to go over section 4.2, which is about solving application problems using systems of equations. So before we get started, a couple of things. One is many of the problems that you'll see in the section could be done using single variable methods that we've already studied. So a lot of the problems in this section may appear familiar. Having more than one way to do something is valuable. Sometimes one method resonates particularly well with certain people, and other people may prefer another method. So it's nice to have more than one method for solving certain kinds of problems. The next thing is the overall plan is we're going to go over kind of the steps that you would follow in any of these problems, and then we'll see some examples. So overall, the steps to follow, and some of this is applicable to problem solving in general. Some is specific to this section. You have to read and understand the problem. That's kind of an overlooked component to this sometimes. You have to make sure that you're able to read and understand the problem as it's stated. You may need to read the problem more than once. Frequently in math, every single word means or matters, and so you have to read very carefully. You may have to read more than one time. Make a picture if the problem has some sort of geometric interpretation, if it's about the perimeter of a rectangle or something like that. It can be helpful to make a picture. Even if it doesn't have a geometric kind of interpretation like that, it can be helpful to organize the information that you're given in a table. That may help you to understand the problem. Okay, step 2, you need to know what it is that you're trying to find. Are you trying to find out how many dimes Alice has? Are you trying to figure out the width of the rectangle? What is it you're trying to find? Frequently in math, you're told a long story. It's a long story problem, and then at the end, it tells you what it is that you're looking for. So look to the end to see what it is that you're trying to find. Choose variables. If we were doing this using a one variable approach, then we would pick out one variable. Frequently in this section, we'll be picking out two variables because we're looking for things: the length and width of the rectangle, how many nickels and dimes Alice has. We're looking for two things, so often we'll have two variables. Often the two variables that we're choosing should be the two things that we're trying to find. Okay, translate the story that you're given into a system of equations. Frequently there's kind of one sentence in the story that corresponds to each equation, as you'll see. Solve the system of equations using algebra, and then check and make sure that your answer makes sense. For example, if the problem is about somebody having a jar of coins, they're not going to have 17.5 nickels, right? You should have just whole numbers of coins, whole numbers of people, things like that. Okay, you shouldn't have a negative width on a rectangle. Okay, so let's get started with some examples. So here, this is just kind of a typical number problem. Here it says the sum of two numbers is 10. We know that one number is 4 less than the other. We want to find the numbers. So here there's a total of 3 sentences. The last one is the one that tells us what to do. We're just finding these two numbers. The rest of it describes the numbers. I'm just going to call X and Y the numbers for clarity's sake. So we've described the variables. They're going to be just the two numbers that we seek. So the first sentence says the sum of the two numbers is 10. That means that if we add together the two numbers, it should be 10. So that is basically what our first sentence is telling us. Okay, then the second sentence says one number is 4 less than the other. So maybe I should be more specific about my variables. I'm going to let X stand for the one number. And then Y will be the other number. Okay, just so I can be really specific about it. Okay, so one number, that's X, is 4 less than the other number. Okay, so there's our system of two equations and two unknowns. Make sure that you can read through the sentences in the problem and come to the same set of equations as we have here. Once you have the system of equations and it makes sense to us, then we can go ahead and solve it. Luckily, this one is pretty good for substitution. So let's substitute the second equation into the first. So X, which is Y minus 4, plus Y equals 10. So we have 2Y equals 14, and that makes Y 7. Okay, back substituting. x is y minus 4. So that means that x will be 3. The two numbers. All right. Then two numbers. All right, so there's that. So that was a pretty simple question in a way. There's not really too much to it. There's only 3 sentences, not too complicated. Okay, so then let's go on to our next one. All right, so let's try this next one next. This one is quite a bit lengthier than the last problem, but our first step will be to read through it and make sure we understand. So here it says, Aaron spent 30 minutes on the rowing machine and 20 minutes lifting weights at the gym and burned 430 calories. So the two kind of activities in the question are that Aaron is rowing and also lifting weights. The first sentence tells us how many calories she's burning doing these two separate activities. Then in the next sentence, we're told that she spent 50 minutes rowing, 10 minutes lifting weights, and burning 600 calories. So that second sentence gives us kind of another combination of rowing time, weightlifting time, and calories. So that'll turn into our second equation. And then lastly, 2 sentences. How many calories did she burn per minute on the rowing machine? How many calories did she burn per minute on the lifting weights? So the last 2 sentences are the parts that are just asking us to solve the problem. So there's not as much content there, and that's okay. So variables, I'm going to make x be the number of calories. Let me make that thing up a bit. This will be rowing. X will be the number of calories that she spends rowing per minute. And then Y will be the number of calories burned per minute lifting weights. It's a good idea to define what your variables mean. I know it can seem like it's extra work or takes extra time, but it really helps you get the right answer. It really helps you proceed through the problem if you're really sure what each of the variables represents. Okay, so now we're going to figure out what each of the 2 equations is. So for the first one, she spent 30 minutes on the rowing machine. So the number of calories burned in that time will have to be 30 times x. If she burns x calories per minute rowing and is on the rowing machine for 30 minutes, then it'll be 30x total calories burned. So that's her calories burned rowing. Then in the same visit to the gym, she spent 20 minutes lifting weights. And so the calories burned lifting weights is going to be 20y. And that totaled 430 calories. Okay, that takes care of our first equation. Next, the next time she spent 50 minutes on the rowing machine and 10 minutes lifting weights and burned 600 calories. So you'll notice that both of these equations have a multiplication, another multiplication, and the results are added, and that's equal to a number. Often you'll see that structure in these types of problems. Okay, so this is our system of equations. Make sure that you can see how we got that from the wording. And next up, we'll be going ahead and solving that system. Okay, so one thing that you'll notice as we proceed into more story problems is that the numbers are not so much just like 1s, 2s, and 3s, right? So it's worthwhile to take a few minutes to try to simplify the equation sum. In this case, notice that both equations, all the constants are divisible by 10. So I'm going to go through and divide by 10 in the first equation. We'll have 3x, 2y, and that's 43. For the next one, I'm going to divide through by 10 also. So 5x and a y and 60. Now, this is a lot easier to process, right, without that extra 0 in there. So to solve this one, I think it'd be a good idea to use elimination. We're going to eliminate y's. I will go ahead and multiply that second equation by -2. That will give us negative 10x. Negative 2y is negative 120. And then let me recopy our first equation. Okay. So now when I add together those two equations, we'll see those y's get eliminated. So we should have negative 7x, and then 43 minus 20, 77 negative. Okay, it looks like x is going to be 11. Okay. Once we've got our value for x, we can substitute that back into any of the equations to get the value for y. So let me put that into this equation. So we'll have 5x. So we'll have 5x plus y equals 60. Here our x was 11. 5x then is 55. And so it looks like our y is itself 5. So now we've got our values for x and y. And this is part of the reason it's a good idea to tell what each variable represents, because now if you didn't know any better, scroll that away. Do you remember if y was the rowing or the weightlifting? We better know, right? Because we've got to write down the answer. So x was the calories spent rowing. So 11 calories per minute rowing. And then 5 calories per minute on the weights. If you are doing this in a math class where you are doing paper assignments, make sure you write out your answer clearly like that. If you're using some sort of online homework system, like My Open Math or something, then frequently the problem will ask you, okay, calories rowing, and then you type the answer into a box. Calories on the weights, type the answer into a box. Make sure you put the right number in the right box. It's unfortunate to go through all this work and you it appears that you miss it because you put the wrong number in the wrong spot. Okay. All right, next we're going to do some applications from geometry. So a little bit of definition first. Angles are complementary if they add to 90 degrees. So examples of complementary angles would be, for example, 60 and 30. 60 degrees and 30 degrees add to 90 degrees. 40 degrees and 50 degrees are examples of complementary angles. In terms of a picture, we know what a right angle looks like. Frequently, you see the little box in the corner to indicate that it is a right angle. So two angles are complementary if they form that right angle when you add them together. Okay? Complementary angles. Supplementary is if they add to 180 degrees. 180 degrees, sometimes called a straight angle. So examples might be 120 degrees and 60 degrees, or of course 100 degrees and 80 degrees. Okay, complementary add to 90, supplementary adds to 180. Couple of things to remember about that. Complementary, this is the version of complementary that has an E in it in the sense of completing. It's not complementary with an I, like something that is free. Okay, like, you know, complimentary breakfast at the hotel. It's not that one. This is complementary with an E in the sense of completeness. Also, if you have trouble remembering which one's complementary and which one's supplementary, what works for me is to remember that 90 is less than 180. In the alphabet, C comes before S. So I can associate the C with the 90 and the S with the 180. Okay. All right. So that's the background we're going to need to help us answer some of these questions. So here it says the difference of two complementary angles is 20 degrees. We're to find the measures of the angles. So I'm going to let X and Y be the two angles. And we're told the difference of these two angles is 20 degrees. Difference means subtraction. So I can say that X minus Y is 20 degrees. And then you'll notice this problem has only two sentences in it. That first one that I turned into X minus Y equals 20. And then the second one just tells us to do it, find the measures of the two angles. So it can appear that we don't have enough information. However, notice that we're told that the two angles are complementary. And so that's the clue that is going to tell us what that second equation is. Since they're complementary, they have to add up to 90 degrees, right? So that's the fact that gives us our second equation. Okay, luckily the system of equations here is pretty simple to solve, so that's nice. We're going to just add together the two equations. We'll get 2x is equal to 110, so that x is 55 degrees. Okay, once you know that x is 55 degrees, then we can back substitute it to figure out what y has to be. I'm going to use the first one just because the numbers are a little bit smaller. So 55 minus y is equal to 20. And so y has to be 35 degrees. Okay, so the two angles are 55 and 35. Okay, so that's pretty nice. So now we should have one that has supplementary into it also. So let's take a look at that. All right, so for this one, it says two angles are supplementary. The measure of the larger angle is 12 degrees more than 3 times the measure of the smaller angle. We're to find the measures of the angles. So on this one, I was more specific about what the variable names would be. Before, I just said let x and y be the two angles. This one, I was more specific about it because the problem refers to larger angle and smaller angle. So I figured we should give a name for each one. So x will be the bigger one, y will be the smaller one. Okay, so now equations. We know the two angles are supplementary. That means that x plus y has to equal 180 degrees. And then additionally, it says the measure of the larger angle, which is x, measure is, that's our equals, 12 degrees more than 3 times the measure of the smaller angle, which is y. So x will equal 12 plus 3y. Okay, so that's our system of equations. Once again, make sure that you're okay with that before we proceed. This one is pretty nice for substitutions. We will use substitution. X is 12 plus 3y. We'll put that into the first equation. So we'll have 12 plus 3y plus the other y, is 180. Combining terms, we'll have 4y plus 12 is 180. Subtracting the 12 from both parts, we'll have 168. And then y will be 168 over 4, which is 42. It looks like 42, and that is the smaller one. And so we can subtract from 180 to find the measure of x. So let's do that. So x will be 180 minus y, which is 180 minus 42. And that's 138. If you like, you can put it into the other equation to just kind of double check that it's right. But I think we are okay. Once again, if you're doing this in some kind of online homework, make sure you put the right answer in the right box. All right, so that takes us to the end of this first part of section 4.2. In the next video, we'll do a couple more geometry examples and then look at some uniform motion problems. So in the meantime, let me know if you have any questions and have a great day.